Okay, so besides the values of all the trigo that you need to know from all the quadrants, right? Generally, for A-level syllabus, you also need to know how to sketch a graph. Okay, for all the sine function, cos, and also the tangent function. And then at the same time, also you need to learn how to actually apply the transformation of graph concept on all these graphs. All right, okay, so like in previous chapters, right, we already learned how to transform the graph, but we actually didn't cover the sine graph, cos graph, and tangent graph also that time. All right, so now you need to learn how to apply both of them together, all right, by using the transformation of graph on the sine, cos, and tangent graph here, okay? All right, so let's have a look for the basic of all the graph. Okay, so for the sine graph in exam, right, if let's say they want you to sketch the graph, they will actually tell you from where until where, from what domain until what domain they want to cover. Because if not, your sine graph is actually a very long graph because it is repeated after a certain cycle. All right, so in exam, they will mention it clearly. All right, so like maybe they want you to sketch only from 0 until pi or 0 until 2 pi and so on. Okay, so you'll see that in the graph that I show you here, the first graph we have is sine x graph, y equals to sine x. Okay, and then the graph that we draw in bold color, in a black color, as you can see here, okay, it is actually one cycle of sine x graph. So you can see that for sine x graph, one cycle means start from 0 until 2 pi. Okay, so from 0 until 2 pi, start at 0, 0, and at 2 pi 0. Okay, and then the graph will go up until the maximum point, which is 1, and then go down, okay, until the minimum point, which is 1, and then go back to 0 again. So if you look at it carefully, if they're asking for the range between sine and cos, then this is how we look at it. So you'll see that your graph go up and down between the value -1 and +1. Therefore, the range. Okay, so the range of x graph should be equals to. So when I write out, I will write out like that. Okay, so the range of the sine x graph. Okay, y equals to sine h. Sorry, maybe I should write something like this. Range is equals to -1. So that means the sine x is between -1 until 1. All right, so this is a basic graph for the sine x graph for one cycle. Okay, and then from this graph, generally it's very important because you need to memorize it. Okay, and then when you memorize it, you have to know a few important values from here because there are a few values. Usually when they ask you to get the solution or get an answer, you cannot get it from other method. You can only get it from the graph here. Okay, so the first one is you need to know. Okay, so when x equals to 0, y equals to 0. All right, so like this one, you are having x equals to pi, y also equals to 0. And also for this one, when you are having 2 pi or 360, you get the y equals to 0. So this value are very important. So as an example, if I say you're having y equals to sine x, okay? So when you want to have sine x and equals to 0, what's the value of x? So usually you will press sine inverse 0. Okay, when you press sine inverse 0, the calculator itself will only give you one value. But if let's say you want to solve it for more values, all right, 0, 0, 0, okay, all the three values here, you can only get it by memorizing the graph. So you know that sine inverse 0, there are three values. The first one is 0, the second one is pi, the third one is for 2 pi. So all the value here, you can only get it from the graph. Okay, because I know that sometimes last time you learned the method, right? When you solve the trigo equation, you need to go through the quadrant and see what answer will you get, right, from quadrant to quadrant. But from sine x equals to 0, okay, you cannot get all the answer from the quadrant, but you just can only get an answer by looking at the graph. So that's why I say the graph is very important. Okay, so this is one of the important value that you need to know. Another important value is this one. Okay, this point. So that means when x equals to pi over 2, your value of y is equals to 1. Okay, so that means also like if let's say you're having sine x equals to 1. If you want to get the value of x, when you press calculator, sine inverse 1. Okay, so of course, the calculator will give you 90 degree or pi over 2. But if you want to know more than one answer, or maybe the answer for more than one cycle, then generally you need to look at the graph. Where is the next value that you'll get the 1? So the next value that you'll get the 1 is 5 pi over 2. So you can put it as 5 pi over 2 and so on. Alright, then same thing happens for the negative 1 here. Alright, so for this negative 1 also, the value is 270 degree or 3 pi over 2. Okay, so although the graph looks simple, but actually they provide you some important information inside in it. So you have to make sure that you know all these basic values here. Okay, usually the value that you need to know is when y equals to 0, when y equals to 1, and also when y equals to negative 1. So what is the value of x that you have during that time? Okay, all right, so this is the basic idea for sine graph. Okay, so you'll see that if let's say I tell you some properties here, some simple intro about the sine graph, you'll see that the sine curve is continuous. That means it has no breaks. And then the range of sine x is between negative 1 until 1. So I think this is important. Okay, so the period of the sine function is 2 pi, and then sine negative x equals to negative sine x. Okay, so this formula to some of the students, it is quite useful. But for me, I don't really use it. I will still use the negative angle idea to get the answer. Okay, so I understand that some students, they just purely memorize the formula. So if you want to memorize, you can memorize. All right, but again, to me, the basic technique that I teach you, maybe in the previous video, is still the very useful one. All right, so this one is purely memorizing, but you don't actually understand how you get all the values. All right, okay, so to me, I still prefer you to go back to the basic method. Yeah, all right. Then now let's continue to the next graph. So the next graph is cosine graph. Okay, so for cosine graph, it is a bit different from sine. You'll see that the very first value they start is from 1, 1, 0. Then the graph go down and then come up again. And then if you look at the range, again, the highest value for the graph is negative 1. The lowest value for the graph is, the highest value for the graph is 1. The lowest value for the graph is negative 1. Therefore, you still can say that the range is what? It is from negative 1 until 1. Right? And the same thing happens. You need to know what is the value that you have when cos x equals to 1. So when cos x equals to 1, x equals to 0. And also x equals to 2 pi. So let's say y equals to cos x. And then now they say that y is 1. So cos x equals to 1. When you press calculator, for cos inverse 1, right, the calculator will give you a value of 0. Okay, but of course, there are more than one x which contribute the cos x equals to 1, right? Therefore, what you need to do is, again, you can only get the next value from the graph itself. You cannot go through the quadrant and get the answer. So from the graph here, you can see that when x equals to 2 pi, all right, so when x equals to 2 pi, your y is equals to 1. All right, so all these values, you can only get it from the graph. So another important value here that you should know is this one. Okay, so when cos x equals to 0, what do we have? So if you press calculator again, cos inverse 0, the calculator will only give you pi over 2. All right, so to get the next value here, you need to look at it from the graph, which is 3 pi over 2. Okay, so these two value is cos for these two value equals to 0. And the last one, of course, you need to know the value for negative 1. So when cos equals to 180, you're having the value cos x equals to negative 1. Okay? Can all right, so this is what we have for sine graph and also cosine graph. Okay, then again, look at the properties here. All right, so for the properties here, generally what we have is, again, all the details you can go through with it. And then the important part is this one only. I just want to mention it to you. Cos x, the range for cos x is between negative 1 until 1. Okay, so this is what we have. All right. Okay, then again, Now we are going to apply all the transformation of the sine and also the cosine graph. For all the graph below, right, they want you to sketch one cycle. Alright, but in exam, right, when they want you to answer all these kind of questions, they will actually tell you clearly, okay, how many domain that they want, okay, or how many cycle they want, and so on. Okay, so let us have a look for the first part. When you're having a basic function plus a or minus a, generally you are moving it. Plus a is a units up, minus a is you translate it a units down. So all these are quite basic. Hopefully you still remember how to do it. Okay, so here I will show you the graph. Okay, so for example, if let's say they want you to sketch y equals to 0.5 plus x plus sine x, and also y equals to sine x minus 1. So the first graph is plus 0.5 outside the sine x, another one is minus 1 outside the sine x also. Okay, so maybe for me, I will sketch all the three graphs for you here. Okay, so if you roughly know how to sketch it, right, I will suggest you also you can draw it yourself first. Okay, you can draw it by yourself, and then after that only we discuss it together also can. Alright, so I want to draw one cycle, right? So I roughly sketch the graph and have a look. Maybe for this one, 4 unit as degree. Okay, so maybe I'm having pi over 2, then pi, 3 pi over 2, and then 2 pi here, and this is 0. And then for my y, I put it as 1 and also 2. Negative 1, negative 2. Okay, and after that, I will try to sketch the original graph first. So the red color will be the original graph. Okay, so in exam, of course, you don't need to sketch the original graph. But this one is, I just want you to have you can compare the graph that you have. And also after you translate it. Okay, so this is my original graph for y equals to sine x. Okay, so red color is y equals to sine x. Okay, so now for the first part of the graph, the first graph, they want to translate 0.5 unit up. So if let's say they want to translate 0.5 units up, you use all the point here as a reference point. So there are a lot of reference point here, right? So for every single point here, you move it up by 0.5 unit, which is 2 boxes in my graph, right? So move up. So you plot 2 boxes above the original point, and then you join them together. Okay, so if your graph is drawn nicely, you will see that the shape is exactly still the same, just that the graph now become y equals to 0.5 plus sine x. So you're moving it 0.5 units up. Okay, then how about if let's say you want to sketch y equals to sine x minus 1. So the same thing happened here. For all the reference point, you move it 1 unit down. So this one originally is 1, right? When you move it 1 unit down, it will become negative 1. Same thing happened for the other thing here. Okay, so 4 box below, 1, 2, 3, 4. Okay, so if you sketch it correctly, you'll see that your graph becomes something like this. Okay, so this is y equals to sine x minus 1. Alright, so I think the idea is not hard generally, but you just need to make sure that you know how many important points in the sine x graph, so that when you can make it as a reference point, so that when you want to translate the graph or whatsoever, right, you can use all the point as a reference. Alright, then you adjust the value from that. Okay, alright, so let's have a look for the next part. Okay, so when we have either a plus a inside the bracket, inside the basic angle, or sorry, inside the basic function, or minus a inside the basic function, then generally, if plus a inside the basic function, you need to translate it a unit to the left. And if let's say you're having minus a inside the basic function, then you have to translate it a unit to the right. Okay, all right, so what do we have here? Then maybe we can take this as example. If let's say they want you to sketch y equals to cos x minus pi over 2. cos x minus pi over 2. So you see that the minus pi over 2 is inside the basic function. Okay, so no matter how, I will draw the basic graph for you first. Okay, so for the basic graph, I have to label everything first. Okay, so again, I will make 4 unit as 90 degree. So this one is pi over 2, then pi, 3 pi over 2, and then 2 pi. Okay, so maybe this is 1, and then this is -1. So my important point is cos x, right? So it starts from 1, 0, 1, and then pi over 2, 0, pi -1. Okay, so you will see that you need to be very familiar with the basic graph, right, for all the cos and sine. Okay, so this is the graph that I have. Okay, all right, then after that, you want to sketch the graph for cos x minus pi over 2. Okay, minus pi over 2 inside the basic function means that you have to translate pi over 2 unit to the right hand side. Okay, translate pi over 2 unit to the right hand side means how? Okay, so as an example, this one, original x is 0, right? You want to translate pi over 2 unit. So in the ratio here, pi over 2 unit means 4 boxes. Okay, so that means I need to translate the point 4 boxes to the right hand side. So that means if let's say this point, I translate 4 boxes to the right, it will become something like this. Here, can you see that? Okay, so for this point, when I translate 4 boxes to the right, it will become this point. This one, 4 boxes to the right. This one, 4 boxes to the right. This one, 4 boxes to the right. Okay? Then after that, when you sketch it, it should look something like this. You connect all the points together. Okay, so this graph itself is y equals to cos x minus pi over 2. Okay, and then this one is y equals to cos x, the original graph. So you can see that we are moving the whole graph 4 boxes to the right hand side, which is pi over 2 unit for our ratio that we are using here. Okay, all right, so next one. Okay, so for the next one is when you multiply negative outside the basic function, that means it is a reflection of the graph through the x-axis. And then when you are having a negative inside the basic function with x, x minus 0, then generally it is a reflection through the y-axis. Okay, so the same meaning here. Okay, so I think I mentioned it to you before. So this one, the reflection of the graph through the y-axis, it actually should look something like this one. Negative x minus 0. That means it is reflected at the line x equals to 0. So the y-axis means x equals to 0. So the y-axis is the mirror. But if let's say you're having the value, which is maybe something like x minus pi, then that means when you want to reflect it, right, left, right, through the line x equals to pi. Most of the time, they are asking to draw through the y-axis, because usually you give you negative x only. But there are some example. They might have some example or special question. All right, they ask you to reflect on a certain line. So you should know about this also. Okay, so I think I mentioned it to you before. Okay, all right. So let's start how to sketch the graph y equals to sine negative x. Okay, so to reflect this one, the mirror is y-axis, right? Okay, so the mirror is y-axis. Therefore, maybe I need to draw my y-axis in the center here, because you have to reflect it left, right. Okay, so I think this is the way that we do it. So I will draw the y in the center. Okay, then again, I need to draw the original graph first. So I'm still using 4 boxes as a 90 degree or pi over 2. Okay, and then 4 boxes as 1 and -1. Okay, so for pi over 2, so sine graph, this is the original sine graph. Okay, so when I sketch it, this is the original sine graph. But when we multiply a negative inside the basic function, then you have to reflect the graph left-right. So left-right means that the mirror is the y-axis. Okay, so y-axis will be the mirror. So you reflect it left-right. So this one is this one. Okay, then again, I'm having pi over 2, which is negative, and then negative pi, negative 3 pi over 2, and then negative 2 pi. Okay, so again, for pi over 2, you're having this point, so you reflect it to the left-hand side, it will become this. This point, when you reflect it to the left-hand side, it will become this, and so on. So you just assume that the y-axis is the mirror. So after you plot all the points, you will see that your graph will look something like this. Okay, so this is the graph y equals to sine negative x. And for this is y equals to sine x. Okay, so this is how we get the graph. Okay, so again, I cannot show you all the example for all the transformation. Then I hope that you can get some idea roughly from here. All right. Okay. Then for the next one. Okay. So for the next one, we are talking about stretching, compress, and everything. Okay. So now, if let's say you are having A, okay, is a stretch of the graph by A units parallel to the y-axis or in the y direction when you multiply the A outside the basic function. Okay, so again, when you have the A outside the basic function, right, multiply the A, the value of y will be affected. Value of x will not be affected. Okay, so again, let me start. Okay, so I think we need to make the scale a little bit smaller because we need to have higher value, higher graph, because 3, right? 3 multiplied with fx. Okay, so maybe still 4 boxes for x-axis. Okay, and then for the y value, maybe I put 3 boxes as 1 unit. I need to have until 3. Okay, so -1, -2, and then this is -3. Okay, so I plot the original graph first. This is the original sine. Oh, sorry, they want cos graph. Okay, so cos graph, the first point is here. Then this one. Okay, and then you have something like this. Okay, so this is my original graph. And then now they want you to sketch a graph that multiply 3 outside the cos x. So when you want to multiply 3 outside the cos x, that means the value of y, you need to multiply 3 as well. So like this one, the original value for y is 1. When you multiply the 3, it will become 3. So your graph need to plot at this point. Okay, and then how about the next one? So for next, the y value is 0. So 0 multiplied with 3, it is still 0. Therefore, it remains the same point here. For this point, the original value is -1. When you multiply it with 3, you'll get -3. So you plot it at -3. Then this one, you'll have 0 also. Okay, therefore, this one multiply it with 3, you have value 3. So after you plot the graph, you'll see that actually your graph looks like becomes slightly more and longer. That's why it is a stretch in the y-axis, right? Okay, so if you try to join all the points together, so this is how your new cos graph looks like now. Okay, so if you compare it with the original one, then you can see very clearly that your graph become longer and also slimmer if you compare it with the original graph. Can see that or not? All right, so this is how to plot the graph with the y-axis stretching. Okay. Can all right. Then next one. How about for the x? Okay, so when I multiply the a inside the basic function, then it is a compression of the graph. Okay, with a period of 2 pi over k. Okay, so I understand that maybe last time when you learn about this, right? Generally, when you're having sine 2x, then you know that you have to draw 2 cycles in the original graph. Okay, if let's say they are having 3x, then that means you need to draw 3 cycles in the original 0 until 2 pi. Okay, all right, so but for now, because I feel that when you want to squeeze your graph into a certain part, certain range, it is very hard. Because if let's say 2 pi still okay, when you have sine 2x, you want to draw 2 cycles from 0 to 2 pi, I think it's still okay. But if let's say when you want to squeeze it become 3 cycles from 0 until 2 pi, then it's very hard for you to label the value of the x-axis correctly, the x-intercept correctly. Okay, or maybe it's very hard for you to draw it nicely. Okay, so here we will suggest a method. All right, so if let's say they want you to sketch 1 cycle from sine 2x, for sine 2x, generally we need to do it like this. Okay, so first, the method here is a bit different. Okay, so no matter how, I still need the original graph first. Okay, so this is the original graph. Wait. Okay, so again, I'm still using the same ratio here. Okay, and then I'm having 1 and also -1. Sine, okay, I draw sine x first. So sine x, the original graph will look something like this. Okay, so this is the original graph that we have. Okay, and then after that, because they want you to, they multiply a 2 inside the basic function. Okay, so when they multiply the 2 inside the basic function, when you want to, so usually for you last time, right, you will try to squeeze it. So squeeze it means that you'll make it become like, there are 2 cycles, okay, in the range. All right, but now I'm not going to do that. Okay, so when you have sine 2x, generally what you need to do now is you try to look at every single value, important value, like this one for pi over 2, right? When you want to compress it as sine 2x, you take the original value divided by 2. So you get pi over 4. Therefore, the label here now, I change it become pi over 4. Same thing happen for this one. Original value is pi. So you take pi divided by 2. Then this label now will become pi over 2. Okay? Then same thing happen. 3 pi over 2, when you divide it by 2, you will have 3 pi over 4. And then 2 pi divided by 2, you will have pi. So here we completed our 1 cycle from 0 until pi. Okay, but of course, if you want to extend it until 2 pi, then you just draw more. Okay, but when you label it, you take the original value of x divided by 2. Because of you are having a compression in x direction, okay, in x-axis, which is the number 2. If let's say you're having a 3 here, that means all the label for the x-axis, you divided it by 3. Okay, if let's say divided by 4, you're having 4x here, then everything here you divided by 4. That's it. Okay, so this is how we do this kind of graph. Instead of I try to squeeze everything inside and then I try to guess what is the label. So I straight away take the label divided by the number given in the question. So I think to me this is easier for me to draw a nice graph, also easier for me to actually label it out clearly and correctly. Okay, all right, so this is how we sketch this compression of the graph when you are having a number inside the basic function. Okay, so this now is because now it will become sine 2x. Okay, so the last one, this one might be a bit special for you. So I hope that you can learn up this method and then you try to apply it when necessary. All right, okay, so this is what we want to cover for our transformation of graph for sine and sine x and also cos x. Okay, so hopefully you roughly know how to apply both concepts together now. Okay, then if we continue further, there are some relationship. Actually, there's a relationship between the graph of sine x and also cos x. Okay, because if you look at the graph here, the red color one is cos x, the blue color one is sine x. So you can see that if you want to check about their relationship, when you are having this point here, and then another point is pi over 2 unit to the right hand side. Okay, so if you look at this one, originally it is red color graph. Then if you refer to it, it is again pi over 2 unit to the right hand side for the blue color graph. Okay, so which means if you are having cos x, you can also write it equals to sine x minus 90 degree or 90 degree minus x also can. All right, so this is the relationship that you can see from the graph, and when they try to summarize it, so this is the summarized formula. Okay, so sine 90 degree minus x equals to cos x, or cos 90 degree minus x equals to sine x. Okay, so I take some very simple example. The meaning is something like this. If let's say you're having sine 30, the value if you press a calculator, it is equals to cos 60. So that's 30 plus 60 equals to 90. So sine 30 plus cos 60 value is the same. Okay, if let's say you're having sine 45, the value is equals to cos 45. All right, so if you don't believe, you can try to press the calculator and have a look. If let's say you're having sine 10, so what is the value of cos? It will be 80, and these two values will be the same. All right, so this formula again, we will not apply it very often, but we will still need to use it in some of the special questions. Okay, so this one we call them as complementary angle. Okay, all right. And then after that, if you realize the graph that we covered just now, mainly we focus on sine and cos. How about the tangent graph? So the graph will look something like this. Okay, so for the tangent graph, it is a bit special because the range of tangent is from negative pi to pi. Also negative sigma, negative infinity to positive infinity. And then you will see that there are a lot of asymptotes here. Okay, so all the line here, pi over 2, this one is 3 pi over 2, are actually the asymptote for tangent. So there are asymptotes here. So the tangent is actually not continuous because it is, you can see that it is drawn for a few pieces. There's a break between the graph. So therefore we call it as uncontinuous or not continuous. Okay, for sine and cos graph, they are continuous. Okay, all right. Then the infinity, the range is from negative to positive infinity. And then the period is pi only. And this is formula for the negative angle for tangent. Okay, then why we, in the previous graph, we only discussed mostly on sine and cos. Because for tangent x graph, we seldom have, they seldom test you on tangent graph. Okay, because of, first, when you look at the graph, if you want to shift it up or down, right, the shape still looks more or less the same. Okay, so nothing much they can test it about tangent. So especially when you're having the negative infinity to positive infinity as a channel. All right, so when they want you to test, when they want to test you about the range for the tangent, also nothing much they can ask because all the range is always negative to positive infinity. Okay, all right, so they seldom ask us tangent graph. So to me, right, the sine and cos graph will be much more important. And also you must know that the range of the sine and the cos graph, okay, in this part, comparatively to tangent. Okay, all right, so here, this is quite a long part. All right, so just make sure that you know how to do it. And then in the next video, we are going to discuss on some question that related to all this that we learned. Okay, so if let's say you want, you can try to complete the next 3 examples in our notes first. Then only you view the next video for the discussion and also the solution.